Hello, everyone, again. We're going to go ahead and continue airframe fuel systems. This time we're going to look a little closer at the fuel tank. So this one is on fuel tank design. There's three primary different fuel cells that we'll be speaking about. The first one's the rigid removable fuel tank. And you can see an example of a couple removable fuel tanks. And you can see the area that it goes in to the wing with some fuel tank straps. Many aircraft, especially older ones, utilize an obvious choice for fuel tank construction. A rigid tank is made from various materials and it is strapped into the airframe structure. The tanks are often riveted or welded together and can include baffles as well as other fuel tank features. The typical material is 3003 or 5052 aluminum alloy or stainless steel can be used. There's a drainable sump at the bottom of the illustration. Keeping contaminants out of the fuel delivered to the engine begins with the proper construction and installation of the fuel tanks. Each tank must have a drainable sump. Each fuel tank must allow drainage of any hazardous quantity of water from any part of the tank to its sump with the airplane in the normal ground attitude. Reciprocating engine fuel systems must have a sediment bowl or chamber that is accessible for drainage. Question. The primary purpose of a fuel tank sump is to provide a. What is that primary purpose? Is it to provide a positive system of maintaining the design minimum fuel supply for safe operation? Or B, a place where water and dirt accumulations in the tank can collect and be drained? Or C, a reserve supply of fuel in case you run out of fuel? No, it is the place where water and dirt accumulations can collect and be drained. B. The second type is integral. They cannot be removed because it's actually part of the aircraft structure. That part is sealed off. It's used as a fuel tank. That type of tank reduces weight because you don't have the additional steel or aluminum. And it uses as much space as possible. Here you can even get them in between the stringers. All the seams are sealed with a rubber-like sealant that remains residuant so that vibration will not crack it. In the illustration, there's 3 inspection holes in the structure that allows access to the inside of the tank for replacement of the fuel quantity probes or repairing any damaged sealant. And those inspection holes are not inspected during annual or 100-hour inspections. So do not open up those 3 inspection panels. You'll break the seal to the fuel cell. So leave those alone unless you're specifically told to. So we call that an integral fuel tank, also known as a wet wing, because it's normally in the wing. The only way of repairing an integral fuel cell is by replacing damaged sealant and making riveted repairs, as with any other part of the aircraft structure. Integral fuel cells, because integral fuel cells are usually built into the wings of the aircraft structure, they are not removable. It's I think we pretty much said everything we need to say there. It's a much better picture of one, though. An integral fuel tank. What is it? Is it A, usually located at the bottom of the fuselage? Or is it B, a part of the aircraft structure? Or is it C, a self-sealing tank? No, integral, it's part of the structure. They use that word for other things, but the fuel tank is primarily where you'll see it used. I know you're looking at what about the tank that's sealing? Well, self-sealing. Integral fuel tanks on transport aircraft are A, usually constructed of non-metallic material, or B, readily removed from the aircraft. So far, those two are both wrong, so it's got to be the third one. Or C, formed by the aircraft structure. Another question on integral fuel cells. So it pays to know a little bit about it. As you can see, you don't have to know a lot so far. What are integral fuel tanks used in many large aircraft? Or I'm sorry, why are they used? Is it A, to reduce fire hazards? Or B, to facilitate servicing? And neither one of those are going to make any real difference, whether it's integral or non-integral fuel cell, as far as servicing or fire hazards. Or C, to reduce weight. Bingo. To reduce weight. And utilize as much of the space as possible for carrying fuel. A typical oral question, what is meant by an integral fuel cell? The fuel cell is composed of the structure of the aircraft, which is sealed off and used as a fuel tank. Part of the structure in which all the seams and joints are sealed so that they will be fuel tight. The structure itself then becomes the fuel tank. And what does the term wet wing mean? So basically, these questions are all following the same theme. It's an integral fuel cell that is located in the wing of the aircraft. Somewhat. All right, flapper type check valves. Do we see one here? We see a close up, and here's a nice illustration of one here off to the left. Basically, if many integral fuel tanks have a series of baffles, and you can, well, let's see, let's continue on. It's got a flapper type check valve. You can see that fluid can go one direction but not the other. So there's a little flow in between the two chambers, but it's enough to prevent heavy sloshing. And it also prevents fuel flowing away from the pump and the discharge line of the tank. This check valve allows fuel to flow to the boost pump, but it closes to prevent the fuel flowing away from it. So those are flapper type check valves. Little check valves, flapper type. Certainly more common, or a combination of both. You'll also see these little baffle plates. Here's opened up a part of the wing which was used as a fuel cell, and you can see the little baffle plates attached so that if there was fluid here, it wouldn't just flow very easily from front to back. It would have to pass over these baffle plates. And here's a better illustration where it's not just a little obstruction in the water, in the fuel flow, but it's actually a stringer with a passage opened up in it. So that basically prevents fuel sloshing and throwing the plane off balance. Question: flapper valves are used in fuel tanks to A, reduce pressure, B, prevent a negative pressure, or C, to act as check valves. Fuel tanks, it's actually to act as a check valve. The other two aren't really close. There's other valves that do that in other airframe systems. So, in fuel tanks, flapper valves act as check valves. Many fuel tanks incorporate what type of valve to prevent fuel from flowing away from the boost pump or tank outlet when the aircraft is in a high G maneuver? Was that flapper, check, or dump? Well, we've been calling them flapper valves, but a flapper valve is a type of a check valve. So I would say that, for our purposes, I'd give you probably almost equal credit for either one. Maybe a little stronger for using the word flapper. But check is not a terrible answer. And what is the purpose of flapper type check valves in integral fuel tanks? What was the purpose again? Was it A, to allow defueling by suction? B, to prevent fuel from flowing away from the boost pumps? That's part of it. Or C, to allow the engine-driven pumps to draw fuel directly from the tank if the boost pump fails? No, that's not the function of a flapper type check valve. That'd be quite a bit for that little valve to do. So B, to prevent fuel from flowing away from the boost pumps. Boost pumps are little pumps that are inserted in the fuel cells in order to, in effect, boost the fuel flow mostly in larger aircraft. But I'm going to have a whole presentation on boost valves, so we're just going to cover it a little bit right here. And the purpose of the baffle plate in a fuel tank is there the word sloshing in there? I do see surging, so I'm probably going to jump right to that. Resist fuel surging within the fuel tank, as opposed to providing an expansion space for the fuel, or to reinforce or to help with the internal structural integrity. It could be a secondary purpose, but it would not be the purpose. It's to prevent fuel surging. B. Fuel baffles are installed in tanks to prevent what? Caused by changes in the attitude of the aircraft? Baffles. So where's my surging? Or my, no, surging is right there. So it's surging. Of course, I don't always jump on the first answer, just in case, and you've got a couple minutes to think about it. Okay, it certainly wouldn't be starvation. That's the only one I started to look at for a little bit. Certainly, baffles aren't going to do anything about vapors, but indirectly they do have something to do with starvation. So I had to slow down and think about that one for a second, but it does not take away my surging answer. You can see the word baffles, look for the word surging. Why are fuel tanks divided into compartments or have baffles installed in them? Why do you have the little compartments or the baffles or the flapper valves? It's to prevent surging of the fuel, which will basically affect the balance of the aircraft, and it will also, you can also mention that it prevents the fuel from leaving the boost valves. I mean the boost pumps. Sorry. I'm not sure if that's required, but let's look at the answer. No, it wasn't, so don't worry about the boost pumps. The compartments or baffles keep the fuel from surging back and forth as the aircraft changes its attitude in flight. So those are a couple good words to use. Surging and attitude. A third type of fuel cell. So we have rigid removable, we have integral, and now we're going to see these bladder types. It's a cell that is used to reduce weight, and they are present in the Cessna 402. So if you go out there, we've actually opened up the wings so that you can see the full bladder cell. To support the weight of the fuel in it, the tank depends on the structure of the cavity in which it is installed. Certainly, once this fills up with fuel, you're going to make sure that the structure can actually hold it. And you can see the little snaps where you're actually going to snap it into little spots on the inside of the wing surface. And you've got similar ones on the bottom. Basically, you reach your hand in through the open hole and work the snap into its particular spot. And the opening itself, you're going to use a lot of duct tape on all the seams to make sure that it's going to be riding on a nice smooth surface. They are removable, and I suppose every 20 some years they're going to be replaced. Older rubber bladder tanks were often covered with an engine oil inside when stored, and that can be flushed from the tank when ready to return to service. Not so much anymore. Modern bladder tanks are made of polyethylene and require no inner protection, but a lot of the older questions on bladder cells still have to do with this using an engine oil or another type of oil in order to store it or to protect it. Let's see. I don't have a vivid recollection of it, but let's see what the questions are. It's an excellent substitute for a welded fuel tank. They've been successfully used for both small and large aircraft. We already did talk about cover all the sharp edges with a chafe resisting tape and install a bladder made of thin fabric, which has been impregnated with neoprene or some similar material that is impervious to fuel. All tank bladders have a finite life and will eventually develop leaks. When a tank begins to seep fuel, remove it from the aircraft and either recondition it at an FAA approved repair station or replace it with a new bladder. I have done this once and it is a lengthy procedure. Especially the first time you do it, but I went pretty smoothly compared to the ones doing the other wing. But it does take a you don't open up the wing for one thing. You are all in effect pulling it through the hole, and all of your work is being done through the hole. So that's a little trickier. That's why it's really not a great project in the shop. But you never know. It's out there. We could develop some project around it. Um, you, do, you do have to remove and reinstall a fuel cell, and we have all three available for you to do that. So, and since this is for the night students, this is usually one of your first major projects. So if you get it done early, do the next type. I'd say do all three types, and I'll review what the project looks like, but I believe there's no problem in uh, turning in one for each of the types of fuel cells. Rigid removable, the integral, which isn't really removing it, but you in effect remove a tip tank, and the bladder. All right, if a bladder type fuel tank is to be left empty for an extended period of time, the inside of the tank should be coated with film of, was that engine oil, linseed oil, or ethylene glycol? That was engine oil. A, a film of clean engine oil. How is the weight of the fuel supported when bladder type fuel cells are used? Um, the weight of the fuel itself is from the actual aircraft structure itself. It's not like doesn't have any additional support. Okay, little 2.5 minute review video. See if I've got anything more to say. Yes, I do. All right. I didn't move my slides around, but I'll just have to make it work. Fuel tanks that are part of the structure, that's integral. These structures inside a fuel tank keep the fuel from sloshing. Where are the baffle plates? There they are, B. An integral fuel tank is also called a wet wing, B. Not that the other two are entirely wrong. A repaired bladder tank should be tested for leakage with a regulated air pressure of approximately what? It's going to be low, I'll tell you that. Well, all three of those are pretty low, so um, normally I'd put the slide up front. The correct answer is the lowest one given. Um, so that's about 3/4. The leaks in bladder cells are located by plugging all the holes, inserting ammonia gas into the cell, and rounding the cell out with about 3/4 psi of air pressure. Place a white cloth, saturate it with a phenolphthalein solution over the cell. If there's any leaks, the ammonia gas will escape and react with the uh, phenolphthalein and produce a bright red mark on the white cloth. All right, that's quite a little maneuver right there. But I did run across this question about what regulated air pressure, so in doing my research, this is what I came up with. The inside of a bladder type fuel tank that is to remain empty for an extended period of time should be wiped with, that was clean engine oil. That doesn't look like a new question. Maybe the other options might have made it unique enough to ask it again. Normally, once you've taken one out, yes, you're not going to reinstall it in another aircraft, and I suppose you might have a hesitancy to throw it away right away. Uh, so you could just wipe the inside with clean engine oil if it's one of the older models and store it in some sort of plastic bag. You could fold it. All right, that looks good then. All right, we finished up another one. All right, I'll see you next time. Thanks.